Stem the Violence. Thank you so much for joining us today. It is an absolute pleasure to have you, and we have a whole afternoon, I would say, of fun lined up. I'm very excited to have you with us, and we're very excited to also have the lovely Dr. Simon Foster. I'll be introducing him in just a moment, but first I want to make sure that if you are going to be following along live with us today, please do have your sort of materials ready. You've got your bike pump, water rocket, Coke lemonade bottles, etc. But I know it can be a little bit difficult to get those at the moment, so do feel free to watch this back a little later and join in afterwards with the recording. So do not worry about that. That is an option, but we'd love for you to follow along live. And if it is your first time with us and you haven't used the Teams live event before, I'm just going to quickly go over a few controls for you. So you can play or pause the event at any time just using this play button here. So if you do need to take a break, go grab a drink of water, something like that. Absolutely feel free to do that. You can change your volume using the speaker button over here. Turn us up if we're a little quiet, for example. We also have the rewind or fast forward option over here with this little dot. Drag it over to the left to rewind in case you've missed something, or drag it as far to the right as you can to catch up with us live. There'll also be a little live button for us as well to make sure you're on the cutting edge of the action, and you can see where you are in the video by looking at the timer underneath. We have closed captions available as well if you would like some subtitles mirroring everything we're saying under the screen, and that is a button that looks like two C's with a square around it. We have the settings for those subtitles in the cogwheel, and we can zoom in and go full screen using these arrows facing away from each other. We also have the Q&A available if you click the symbol with two speech bubbles and a question mark inside, which will pop out a panel that looks a little bit like this. Here is where you can type your first name or a nickname perhaps, ask your question in this box below, and then post away using this lovely little arrow down at the bottom. Those will go straight to my moderator, Adrian, who will then sort of publish those if we need to. And I would recommend taking a look at the featured section just here to see the public chat and any announcements that we will be sort of showing there. One thing I would love to do now, though, as we have had our little introduction, don't worry, you'll be seeing us again a bit later, but I would love to introduce Dr. Simon Foster, and he's a solar physicist and space scientist in the Department of Physics and Space Lab at Imperial College London. It's a pleasure to have you with us, Simon.
Hello, thank you very much. Hopefully you can see my screen. Can you? Fingers crossed.
1 second. Yep, it is looking good. Let me just make sure you've got your cam as well. Yep, it looks perfect.
Brilliant. Hello, everyone. Thanks for joining us today. I'm Dr. Foster. I prefer to be called Simon. I'm a space scientist, rocket scientist at Imperial College. And yeah, I always dreamed as a child of being a rocket scientist, a space scientist. And basically, I think the best thing for me to say is if I can do it, anyone can. Because I'm not going to sound particularly bright. I'm just always interested in it. And I want to take you through the basics of rocket science, how to be an astronaut, basically. Fingers crossed one of you will out there will one day become a rocket scientist or even an astronaut. So you can join in today, okay, and use the materials you've got around, like plastic bottles I've got here and things like that, or you can do this later on. So if you don't have the stuff with you, please don't worry, and I may go through it a bit quickly today, okay? So you can rewind or we can watch it again later on. So please don't worry if I've gone too fast, okay? And we've also got some resources that we can send around to you, a pack we've developed that you'll be able to follow that as well. So hopefully this is going to be your first steps into being a rocket scientist. Now, when most people think of rocket scientists, they seem to think of images like this. You can see people, astronauts on the moon. I believe this is Alan Shepard. What they don't think of when they think of rocket scientists are pictures like this. Now, this is actually me. Okay, so this is me, believe it or not. I know I look quite different now, especially my hair color, but this was me a long time ago, a long time ago. And this is how rocket scientists start. This is how astronauts start. We start out just like you. Okay, so don't ever think that there's something strange or we're unobtainable. Okay, you can do it. If I'm living proof that if I can do it, you can do it too. Okay. And today I'm just going to take you through hopefully what we're going to do today. So today I'm going to introduce you to the basics of rocket science, okay? How you design a rocket, the fuels involved, and fins and the nose cone, and parachutes, how we bring our astronauts down safely, the safety features you might need, and how we put it all together, okay? So when you think of astronauts, actually, you should think of people like this because they come in all different shapes and sizes, people, male, female, different races and religions. There have been lots and lots of different astronauts, okay? And we've got some packs for you with the profiles of different astronauts from different countries, okay? Lots and lots of countries have sent astronauts into space. It's mainly the Russian Space Agency and the American Space Agency, NASA, that send them up, but lots and lots of astronauts have been sent up into space. And these are the resources that you might need today. As I keep saying, don't worry if you don't have them with you, okay? We can come back and do this again later with the pack, with the recording. Please don't worry. If you just want to sit back and enjoy this, hopefully you're going to enjoy it, then please do, okay? I want this to be enjoyable. I want you to learn. Basically, the reason I do hands-on events is that I learn as a child, and I still do through building things, through hands-on. I find it quite hard sometimes to learn from books. I'm a bit more of a practical hands-on person. Unfortunately, at school, we're not always taught like that. I certainly wasn't, but it's how I learn. It's how my brain works. And so hopefully getting your hands on, learning this way will help you. And it's just a start. I hope you go further and further. You can build bigger rockets with different fuels. Now, to start off, I want to ask you a quick question. Don't worry too much about, hands up or anything like that. But I was just always like to kick off with, who was the first person to go into space? Now, you may know that, you may not. Now, the first person was actually this chap here. He's called Yuri Gagarin. Okay. And he was a Russian. Back then it was the Soviet Union. Russia was called that. And he went up in the start of the 1960s, I'm trying to think. However, he may not have been the first person to go into space. This is what's quite interesting. At the time, there was a thing called the Cold War, and basically Soviet Union, Russia, and America were kind of fighting each other, but they didn't really want to use weapons because that might blow both of them up. So they tried to use science and other things to actually show who was the best. And the space race, launching human beings into space, was one way that they were trying to demonstrate their superiority. Now, they both built big rockets to launch people up into space. Unfortunately, their rockets frequently exploded. So that wasn't particularly good for launching human beings up. So the Americans actually, and this was top secret until fairly recently, decided to take a novel approach. Instead of launching people on rockets, they took a weather balloon. Now, you may have seen this. Sometimes you see these big, like, silvery balloons that they launch up into the top of space. People now launch like rubber ducks and all sorts. Well, the Americans back in 1957, if I remember, put a human being on one of these and let him go all the way up into space. And his name was Joe Kittinger. So technically, he was the first person to go into space. And Red Bull replicated this a few years ago with a guy called Felix Baumgartner. So, another question for you. So, now, this person was actually my hero, and one of the reasons I actually wanted to become an astronaut didn't happen, unfortunately. I've got asthma, got arthritis in my knees, lots of problems, lots of reasons why I didn't become an astronaut, unfortunately. But this person did. Does anyone know who the first Briton in space was? Again, don't worry about if you can shout out wherever you are, but does anyone know? A lot of people say Tim Peake. Tim Peake was the second British person to go into space. The first British person to go into space was actually 30 years ago in May 1991. This lady in the middle was the first British astronaut. Okay, her name's Helen Sharman. And these are our two Soviet, I should say, cosmonauts that went up with. This is Tolly on the left and Nikolai on the right-hand side. And unbelievably, a couple of years ago, this is me with Nikolai. And you can see there, I was very excited because my nostrils are flaring and I've lost all control of my face. Even more amazingly, I actually now work with Helen. Helen Sharman. So she's now a colleague of mine. Again, I'm going to start smiling, and I feel like I'm a child again. And the first couple of times, I literally couldn't speak to her. I was losing the ability to speak now, because I met someone who basically inspired me on my career, and she's really cool. That's the best thing. She's really cool, really nice. And I say, I can't believe I work with her now. Again, I have to keep reinforcing this. If I can do it, you can do it. Okay. I was never considered that particularly bright at school. I was in fact in the bottom class for a lot of things. So as I say, if I can do it, you can do it. I promise you. Okay. Helen's other claim to fame, I should point out, is she actually worked on the Mars ice cream. So if you ever eat one of that, Helen actually works on that as well. She's a chemist. Moving on. Again, this is actually important for rocket fuel. Okay, I'm going to ask you a question here. When did human beings first try to launch themselves into space? Okay, does anyone know? I've given you three options here. There's about 2,000 years ago, around the time of the birth of Jesus. 1783, which is 230 years ago nearly. God, no. 330, my maths, no, 230 years ago. God, my mental maths is terrible at the moment. Or 1961, when Yuri Gagarin first went up. Actually, human beings first tried to launch themselves into space 2,000 years ago. And to understand that, we have to actually look at rocket fuel and the different types of rocket fuel there are. Okay, and this is your first step into being a rocket scientist, okay? Learning about fuels, which is always fun because you get to blow stuff up. I shouldn't say it too loudly, but you do. Okay, that's rocket fuel, really. You're making stuff that goes bang in a controlled way. And the Chinese discovered the recipe for something called gunpowder nearly 3,000 years ago. In this manual here, you can even see the Big Dipper in it. It's like an encyclopedia they wrote. It's called the I Ching. And they said, whatever you do, don't mix three chemicals together because you might get a fire or an explosion. Now, obviously, mixing chemicals together to get a fire or an explosion, some people might think that could be quite a good thing, actually, as long as it's controlled. And this is the recipe for gunpowder, okay? It's got three things inside it. Gunpowder, rocket fuel, however you want to call it, okay? And these three things are sulfur. And when sulfur burns, it gives you that rotten egg smell. And sulfur can be found in eggs. Okay, so that's one of the ingredients there. Another one is charcoal, so barbecue. Okay, the energy in your barbecue, that's released very slowly, but in gunpowder is released very quickly. And the other thing is something called saltpeter or potassium nitrate. Now, that may sound like a strange chemical and it's hard to get hold of. Have you ever eaten bacon, salt beef, salt fish, anything like that, a preservative, ham even? It's a really well-used preservative in foods, okay, believe it or not. In fact, I don't eat meat, but in Sainsbury's, I do this a lot. I took a picture of the back of a packet of bacon, and there you will see, can you see, ingredients: British pork, which hopefully is important in bacon, salt, sugar, preservatives, potassium nitrate. So one of the main ingredients in gunpowder is found in food, okay? Now what you do is you take your sulfur, your potassium nitrate and your charcoal. You can actually use sugar instead of charcoal, and you mix it up. Now when you first put it in, you've got lumps like this, and what you need to do is grind it. Okay, so you grind it and grind it and grind it. It gets finer and finer, and that way it's a lot easier to, when you put a match to it, it's a lot easier for all those different chemicals to bump into each other, to react, and you get a bang. Okay, now this is what's different between, I suppose you could say, a bomb and a rocket. It's really how you control that reaction. So I've got a balloon here, okay, forgive me. I'm going to blow this up, So, blowing up my balloon. If I keep blowing it and putting more and more air into my balloon, what eventually is going to happen? I won't do that now. If I keep blowing and blowing, eventually it's going to bang. Okay, all that gas inside is going to pop and it's just going to explode. But that's true of when you ignite your gunpowder. Okay, If you don't have a way of all those gases being released in a controlled fashion, effective, you've got a sealed container. These solids, when they burn, they release lots and lots of gases, lots of smoke. You may have seen this on fireworks night or on Diwali. That fills up your container and eventually goes bang. Now, a good way, let me show you this, hopefully. You may well turn your volume down. This is a sealed container with gunpowder. You have an explosion because it's uncontrolled. However, if you control the way your gas is released, if you can release it out of a tube, out of a hole, all of a sudden, instead of it going bang, you have what we call thrust. You have a controlled push. And this is the big difference. And that's what's super important. And this is all thanks to this person here. Now, I don't know if you've ever heard of him or come across him, this scientist. You may, I don't know if any of you recognize him. Now, actually, he did a lot of his work during a plague about 300 years ago, during what was called the Black Death. So there is some kind of link to what we're going through now to what he was doing. He did a lot of work then. And his name is Sir Isaac Newton, one of the planet's greatest ever scientists. Seriously, a phenomenal person. And he came up with 3 laws of motion, one of which is super important for rocketry. And this explains how rockets fly. And his 3rd law of motion states, for every action, there's an equal and opposite reaction. And all this basically means is, if we've got our blown up balloon, if you have a push in one direction, you have to have an equal push, an equal size push in the opposite direction. So if all our gas is coming out this way, we get a push in that direction. Okay, and so if I try and I let go, off it flies. A bit uncontrolled, but you had gas coming out the back, and our balloon or rocket or whatever propels forwards. Okay, equal and opposite. And this is why it's important. Rocket fuel is super important, because the more powerful your fuel, the faster you can have it going out the back of your rocket, the bigger the push. The faster your rocket will go up, the more you can lift. Now, we see this all the time on fireworks night, Diwali, with fireworks like this. Down it goes. Can you see all that gas is going out the bottom? Up your rocket goes. And this is super important. So actually, rocket fuels, explosives, are super important when it comes to rocketry. Now, quickly to go back to 2,000 years ago, actually the Chinese actually discovered this, and there was allegedly a famous scientist called Wan Hu, who was a Chinese scientist. This was about 3,000 years ago, and he decided to place either 36 or 72 rockets, the records are a bit sketchy, around a chair and ignite them. And his idea was that he would then be able to fly around the country. He disappeared in a puff of smoke, never to be seen again. Okay, so it may not have gone that well. Okay, but there's a Mythbusters that you can look up on YouTube as well, where they try this as well, and it does disappear in a puff of smoke. But people were trying to launch themselves into space a long time ago. Okay, and there's a clip of it there. So when you're building a rocket, what have I done with it? I had it here just a second ago. Aha. A rocket engine, rocket motor is no different than this plastic bottle. Okay, and when you're building your rockets, okay, I've got a valve here, and this is what I use these. I'm not employed by them, but I use these rocket kits. You can make them yourselves. You can look up online how you can make one out of a cork. But these work quite well, and we've given the link. Basically, this bottle here is basically just like a rocket engine. Okay, you fill it up with, well, anything you want that it can ignite. Sometimes you could other stuff. I won't talk about it too much, but if you use water to start with, just for your journey, okay, just starting out being a rocket scientist, and you pump it full of air, you get a lot of pressure in there. It's a bit like shaking up a bottle of Coke, and you let it go, and all that Coke and stuff flies out. Okay, that's going to produce a force, a push. If you put this on the bottom, and have some water in it, pump it full of air, what's going to happen is that air, the pressure inside will get bigger and bigger and bigger and eventually push down, force the bung out. And if you've got all that water and air shooting out the bottom, your rocket's going to go up. Okay, so this is the simplest way of making a rocket engine. Okay, I won't talk about it. We can go along your journey, but there are other things you can put in here to launch your rocket. Okay, but this is the easiest way. Okay, just to get started, just to be able to launch projectiles into the air. Okay, and this is a projectile. Now, when we look at it, you can see here, this is Ariane 4 or 5. This is the European Space Agency's rocket that they launch satellites on. And you can see there that you've got all your all that fuel, that heat and energy shooting in a controlled way. And that's the really important thing, out of the bottom. Okay, and that's what you want to do. You want to try and get it out. You want to try and get all the material in here out of this nozzle as quickly as possible, or in a controlled way, so you can launch your rocket up into space. And to give you an idea, this is the old space shuttle. Okay, you can see it here. Now, to give you an idea about these rocket motors here, you can see each one of these is about the size of a house. And in each of these engines, about 5 tons of fuel is being burnt every second. So you go 1,000. That's 5 tons of fuel is being burnt every second in one of these motors, these engines, just to give it the push to launch your rocket up. And to give you an idea, you see these are so hot they've gone white hot. So if you ever seen in like films where, I don't know, like James Bond or Indiana Jones or something, where they put a poker in the fire to scare the person, and it starts off red and then it goes white hot because it's so hot. These engines are white hot. They're that hot. Okay, they're probably about the same temperature as, well, possibly the surface of the sun. They're thousands of degrees. They're ridiculously hot. Now, this is basically your rocket. This is what you've got here. You've got different parts of it. You've got the fins. You've got pressurized air that we're going to pump in, the water inside it, and you can play with how much water and air goes inside it as well. So these are things for you to think about. And you basically, what we've got is thrust, and that's to push up. And that overcomes the weight and air resistance. And we're going to talk about air resistance in a bit. And to give you an idea, I actually launched one of these over the summer. Here I am. And hopefully you'll be able to see it. That's my little boy. Counting down. This is a field rally. Now, you can get it going a lot higher than this. Go up about, they can go up about 100 feet, which is about 30 meters, if you get the water and air ratios, amounts of water and air correct. That's something for you to try out. Okay, super important. So all these things, I'm not going to tell you the perfect way of doing any of this. It's important as scientists, trial and error, try things, may work, may not. It's always super important. Now, moving on. Sounds peculiar using water as fuel, but actually it just produces a push, and actually we can use water as fuel. Sounds bonkers, I know. But water is made up of 2 chemicals, 2 elements, hydrogen and oxygen, H2O. And the hydrogen is slightly positively charged, and the oxygen is slightly negatively charged. You may have heard of opposites attract. Okay, positive is attracted to negative, and likes repel. So positives and positives, if you push them close together, will push apart. It's a bit like a magnet. North and south, bong, come together. North and north will push apart. Now we can use this to pull hydrogen apart. Believe it or not, you can take water, use electricity, be super careful with this, okay? Pull it apart and you get hydrogen gas and oxygen gas. And the great thing about hydrogen and oxygen gas is that hydrogen is actually very flammable. It's rocket fuel. So a lot of that, one of those rockets I showed you earlier, was using hydrogen and oxygen. So believe it or not, water I've got in my cup here, that is actually can be converted into rocket fuel. And it's actually been used as a fuel for cars as well. So it's super important. To give you an idea, this here is this is me with a bowl of water, and I'm just dropping one of the 9-volt batteries in it. You having a smoke alarm. And can you see the bubbles coming off? That's hydrogen and oxygen. You can create with, it's called a process called electrolysis. Now, I captured that hydrogen in a roundabout way, and in a balloon. You can see I'm obsessed with balloons. I've got some safety gear. So fingers crossed you can see that. So you can see there that you can blow that up. Okay. Oh, I don't know what was going on there. And the other way, you don't need to blow the water up, the hydrogen and oxygen up. You can actually use a different method. And this is, does anyone know what this is? Now, you may know that this is called a TIE fighter from Star Wars. Does anyone know what TIE actually stands for? And believe it or not, it does have a scientific explanation. Okay. TIE, I've got to show how nerdy I am. TIE stands for twin ion engine. And an ion is just a charged particle. It's a negative or a positive particle. Okay. A bit like when you rub a balloon, it becomes charged, you can stick it on a wall, it can make your hair stand on end. That's a charged particle. Okay. And what's that's an ion. And what's super interesting is that scientists, some of which I work with, some of which work in STEM of Ireland with us. Actually, one of them is working on a rocket motor, a space motor that uses water. You basically charge that water up, make it positive. You give it a slight charge, and it shoots out the back of your satellite and powers it. And actually, here's another thing I found online of people using electricity, ions like that, to lift things out off. So you can see here, this thing is hovering. This is called an ion lifter. Now, this all sounds very complex. Don't worry, I just thought I'd give you a bit of background about it. But this is using electricity to fly. You see, there's no motor. It's amazing. So there's lots of different ways you can create thrust, push for your engines, okay? We are just looking at one ways with our bottle pressure water, but there are lots of different ways that rocket scientists look at how they can lift things off into space. Now, when you're making a rocket, you've got lots of different sections, okay? And if you want to put a crew or a payload like a satellite on it, you need to think how it's all going to fit together. Now, traditionally, a rocket looks like this, okay? And there are main sections to it. Firstly, you've got the rocket fins, you've got the rocket engine where the gas comes out. The fins help keep it stabilized. Okay, stop it wobbling. They're super important. Without those fins on, it can shoot all over the place. The fins help stabilize it during launch. So you can play around with how many fins you're going to put on your rocket. Okay, the body contains the fuel. Okay, for your water rocket, I should say the bottle you're using put your water in, please don't cut any holes in it, okay? Because when you pressurize it, when you start pumping, all that's going to happen is that the water is going to shoot out in all different directions, okay? So, however, well, we'll look at this in a minute. What you can do is take another bottle, cut it in half. Here's one I made earlier. And you can stick that on top as another body where you can put things inside, or you can put more on top. Okay, that's where you can put your payload. We'll look at this in a bit, actually. And finally, you've got the nose cone. The nose cone is super important simply because this makes something aerodynamic. And you may have heard this before. Aerodynamic means how easy it is to cut through the air. Okay, it's something we'll talk about in a sec, sorry, but you may have looked at sports cars or jet fighters. They all have got, they're very aerodynamic, they're very angular and smooth because it helps them cut through the air when they're like a Formula One car. To give you an idea, this is the Saturn V Rockets. So this took astronauts to the moon. Okay, this rocket. Now, what's amazing is hopefully you might be able to see my cursor. Only, you see the top black line right at the top, there's a little top black line around the top of it. Only that bit up to the kind of point at the top, that bit was the only bit that contained the people. Everything underneath it was fuel. Can you imagine that? It's like only about 2 or 3% of it was actually the stuff you wanted to get into space. The rest of it is fuel to power those massive, massive, massive engines. Okay, so your crew capsule is super important. So, talking of which, when you want to, the easiest thing I always use as crew is an egg. And the reason being is that eggs, like human beings, when they hit the ground too hard, when they get launched too fast, that they have a tendency of breaking. So if you can launch an egg and bring it back up, you're kind of on the way to understanding how a human being will go up. Now, as I said earlier, the easiest way I do is to take another bottle and basically cut it in half and stick it on your rocket engine, okay, like that. And that's where you can put your egg. And you can use now, you may have got lots of deliveries from Amazon, and there are other places available, I should point out. You might have got things like packing peanuts. These are quite good. You can get bubble wrap. Okay, that's all really good for storing your your egg in. Okay, because that helps cushion the blow. Okay, so that's super important. How are you going to think? How you going to launch your astronaut? Okay, this is the crew capsule. You can imagine. Please play around with this. Super important that you experiment and try different things out. Okay. Now, why is this important? Well, actually, on Earth it isn't too bad, but when you're going into space, actually, the space is a vacuum. Okay. And what that means is there's no air outside. So this is what happens in a vacuum. So this is a balloon, okay? And can you see? Sorry, I appear to be obsessed with pink balloons, but can you see as I'm sucking the air out from inside this vacuum chamber, what's happening to our balloon? It's getting bigger and bigger, and this happens on an airplane. The pressure can change. You know, you have to go. Sometimes, if you've ever been on an airplane, because the pressure changes inside the cabin because there's less air outside, and this is what happens. So this is why you've got to make sure your crew are secure inside your rocket. To give you an idea, let's try this one actually. I've got a couple. This also, actually, this is a beaker of water. Now this is super interesting. Look, now you're made of water basically. We're about 70% water. Our blood, keeps us, is what we're made of. Now look what happens to water in the vacuum. Now this I got out of a tap. It's about 30 degrees. Okay, look what happens in a vacuum to normal water. Effectively, this water is the same temperature as your blood. So look what will happen to your blood, or the blood of your astronauts, if they're exposed to the vacuum of space. Now, can you see what's happening? It's starting to bubble. Okay. It's boiling. The water is only 30 degrees, the same temperature as your blood, but it's boiling because the air is a vacuum. There's no air pushing down on it, so it needs less energy to boil. So this is why it's super important, okay, to have a proper crew capsule that's properly contained. Okay, this again is something you need to think about. You can try this out with an egg. Now, the other thing is space is very cold, and let's just think a lot. Okay. Space can be as low as minus 270. That's nearly absolute zero, in which case you can't get any colder. Okay. Now, it was about, in Scotland, I think it's about minus 21. You can get as low on Earth at the poles at about minus 50. Okay. Now, I have got at work a chemical called liquid nitrogen. This is about minus 200 degrees, okay, and you can see I've got that special, that is my arm there, believe it or not. It's a very thick glove. It's called a gauntlet. It's a bit like the big the things that the spacesuit the astronauts wear, okay. And I've put a banana inside our liquid nitrogen, okay. I've sped it up a bit. Now our banana is getting down to about minus 200 degrees, the same temperature as space. This is why it's important that our crew capsule is contained, okay, and you try and protect your astronauts. So this is when the astronauts are going up into space in a rocket, and when they're up there, they need to be kept warm. And this is why spacesuits look the way they do. Protect your astronauts. So this is when the astronauts are going up into space in a rocket, and when they're up there, they need to be kept warm. And this is why spacesuits look the way they do. So hopefully, here I am, fingers crossed. I'm going to get my banana out. Now, bananas are nice and squidgy normally, like your fingers. Well, apart from the bone inside, but they're soft and squidgy like our flesh. Okay, now look what happens to this banana when it's been frozen down to the same temperature as space. Okay, this is the same temperature as space, and I've got a big stick in the lab. It becomes super brittle like glass. Okay, this is why you need to keep your crew protected. So, on top of this, on top of our bottom, the good thing to do is to make a nose cone, as I was saying, and you can test out different ways of different shapes of nose cone. Now, I'm going to show you the easiest way of making a nose cone. So, I'm going to just switch over. There we go. Can everyone see? Hopefully, you can see my hands. Fingers crossed. You can see my hands. Now, I'm going to get some paper or card. You can use card. You can use different materials for this. Please do it. Okay. So, you can see my hands. Now, sheet of paper. Okay. This is the easiest way of my cone. Okay. A nose cone. Pointy shape to fly through. Space and this is effectively what you're trying to make. Okay, hopefully you can see that there. So if I take put my finger here and just roll around like you're making an ice cream cone. Oh, does it come back? Sorry.
It has. I'm also getting a little bit of sort of bubbly audio from you when you've activated that as well.
Oh, okay, sorry. It's probably the microphone on it. Sorry. Sorry, I don't know how to do it. Is it okay?
Oh, much better, thank you.
Okay, I don't know what I did. We just rotate this round. Effectively like making an ice cream cone. Does that make sense? So, you can see it here, put your finger here. Roll this round. Take that over. Doing this super quick, you can do it yourself. Okay, can you see you've basically made a nose cone? You might want to take that off at the top as well. Now, as we've got our rocket here, hopefully you can see me. What you can do is basically just plonk this on top. And you've suddenly got something that looks a lot more like a rocket. It looks more aerodynamic. This is going to help you get higher into the air because the air is going to push down on it less. Okay, this is super important. Now, again, to tidy this up, what you can do is just take your scissors and just kind of go around, just cut around. And you can make this out. I make this out of cards. You test out different shapes. This is what I want you to do. Okay. Again, there's something we've got a cone, just like the one I made earlier. Okay. And all of a sudden, if we place this on top of our crew capsule, you see, we've got it's starting to look just like a rocket should look. Okay, this is super important. Okay, check out different shapes. Okay, you can make this bigger, smaller, blunter. I want you to experiment. Experimenting is the way forward. Okay, guys, super important. Experimenting. And I'm gonna switch back over. Fingers crossed. Yeah. Now, what we need to build is some rocket fins. Fins, as I explained earlier, are super important for making sure your rocket launches into the air and keeps stable, so it will go straight up. It doesn't launch off at strange angles. Okay, so rocket fins are super, super, super important. Okay, this is what one looks like.
So sorry to cut you off once again. We are having the same audio issues. I think it is picking up your mic from both your PC and the little cam.
Better there. Hand it off.
Oh, so much better. Thank you.
Okay, so I've turned that off. So I'll turn it on again in a sec. So this is what our fin looks like. Stick it on. Okay. And this will basically help your rocket stay stable. So if I'm fingers crossed this is gonna work, I'm gonna just turn my visualizer back on again. I don't know how to make sure the microphone doesn't come on. I'm sorry. What I will do is I'll switch over. Fingers crossed. Hopefully, see that turn right on. Hopefully, it didn't go too mad. Okay. So, the way to make a fin, take a bit of card. Okay, I'm going to do this super quick. And simply fold it in half. Okay. Doing this a bit rushed. Then take a pencil and a ruler or a pen. Now I want you to experiment with how you make your fins and the shape. Okay, so the folded edge is at the top. So I'm just going to go do this super quick. Make a line here, line here. So I've basically made a triangle. I'm going to draw a little rectangle off of it. Now I need to cut that out, and I cut. Here's my scissors. So I've got to cut this out. Cut along the outside. Now I'm doing this quick. Don't worry. Now, if I fold this rectangle here, here, and here, all of a sudden I have two tabs and a fin. Hopefully that all makes sense to you. And I can now attach it onto my rocket like such. Now you can build that. I've only shown you how to make one. If you make more and more and more, fingers crossed, you will be able to, you can experiment with how many rocket fins you want to put on. Okay, so 3, 4, 2, whatever. Okay, put those on. You can put them on the top bit as well, smaller ones. Okay. I want you to experiment. You can make them bigger than this, smaller than this, whatever. Okay, you can see I've got different ones there, but it's for you to experiment with. Okay, this is not the be all and end all. I want you to experiment. Super important. Okay, so fingers crossed. And this is what it looks like. This is what a rocket looks like. You see it's got the fins there, and that's to keep it stable when it's launching. Different people, different ways of putting them on. Okay, now the other thing is important is about your egg. Okay, you're going to put inside, and you need to think about how you're going to bring your astronaut down safely, actually how you're going to protect them during launch. Okay, because sometimes, you know, there's G-forces. You may have heard of this. Now the easiest way to show this on experience G-force is actually, have you ever been at a playground and you've got a like a merry-go roundabout? I'm terrible on these, which is another reason why I'm not an astronaut. Okay, now this is one here, and this is, they put people inside this and they test them. Okay, they test to see how they cope under extreme gravity, because when you're launched into space, you feel G-force, several times the pull of gravity. Yuri Gagarin got 9 times the pull of gravity launched into space. And what's super interesting is they've actually, this is actually some footage from inside. I've got some music on as well. Now, can you see in the top left-hand corner is how many times the pull of gravity they're feeling? You see all this stuff gets pulled back because you suddenly feel heavy. You see, it's hard for them to breathe. They have to take short, sharp breaths because their lungs are being compressed. Okay, these people are feeling 5 times heavier. Okay, now to go into space, you feel about 7 Gs on launch. So you feel 7 times heavier. Okay, so you need to have a suit that's pressurized to keep them to stop them squashing, basically, and actually a nice, snug, tight seat for them to go in. So your egg, and I've realised I've been super stupid. I forgot my egg, and we've got hundreds of them downstairs. I actually put it in something like bubble wrap, small like this. This helps cushion it, okay, on launch. So this absorbs a lot of the force that your egg and your astronaut's going to feel on launch. Or you can use big bubble wrap like this. This air cushions the blow, okay, on launch. Or you can use packing peanuts. That, squeeze that. That helps absorb some of the force that your astronaut is going to feel. Now, the other thing that you're going to have to think about is how you bring your rocket down safely, and also where you're going to put your parachute. So the easiest way to bring a space capsule down was actually how we saw with Joe Kittinger earlier, is a parachute. Okay, all at the moment, apart from Elon Musk, and he hasn't done it with humans yet, I don't believe, every human being that goes into space is brought back down with a parachute. Okay, and you need to build some parachutes, or it's good to put them on your rocket. You've got to think how many you're going to need, their size, where you're going to put them on launch. And this is quite good. If you can do it, and you need to experiment, is actually above. This is why I have that extra section on top of my crew capsule. If you put your egg in here, put this on top, okay, now you could put your parachute inside this somehow. When this comes off, maybe your parachute comes out. Please experiment, play around with this, test this out. Okay, to show you what happens, this is the Apollo landing. This is astronauts coming down. Now, did you hear that? They've got 3 parachutes on board. Okay, this is Apollo 11. I think the people that went to the moon, the first people that went to the moon, Buzz Aldrin, Neil Armstrong, and Michael Collins. Now, they had a spare parachute in case it didn't. One of them didn't deploy. They only needed one. One would have been okay. So you can see there, how many parachutes are you going to use? Is one going to be enough? How big is it going to be? Okay, now I'm going to quickly show you how to make a parachute out of a bin bag. Now, we've got a sheet for you on this, okay? We've got a sheet. So please do not worry if you find this hard to follow. Okay, again, I want you to experiment. So I've got a a roll of black bin liners. Okay, now you can pause this. You can see it on the sheet that we're going to send out, that you can download. We've got the instructions how to do this, so please don't worry. Now I'm going to try and maybe if I bring, first things first to do is with your black bin liner. Okay, slow this down if you need to, is cut the handle off. Okay, so the end of the handle, cut that off. You don't need to be too precious about that. The other end, cut the end that's sealed, that's usually the bottom of your bag, cut that off. Effectively, what you're going to have is a big plastic tube. Okay, now I'm going to switch this around. So hopefully you can see on the floor while I'm doing this. I haven't got much room, I'm up in my loft, but fingers crossed you'll be able to see this. I hope the mic doesn't go all wobbly. Hopefully you can see this. Oh, I don't know if it's going to work. Sorry. It isn't. Can you see? Oh no, maybe not. I'll have to do it up the top. Okay, it isn't letting me. Oh, here we go. Hopefully you can see this. So there's my arm, and here's the floor. Okay, so if we take our bag, open it up, clear, you've effectively got a big plastic tube. Okay, put that down on the ground. So you've got the open end at either side. Okay, you've got open end this side, open end this side. Okay, now what you need to do with your open end, firstly fold it in half. So you've got you've got both open ends on this side. Okay, make that straight. Then simply come up here, take this edge, put your finger here and fold the tops over. So you've got a triangle. Fold it again, and I'm doing this quickly, but you'll be able to hopefully do it more slowly when you do it, and on the sheet it'll show you how to do it. Fold it again. So you can see you're making a big triangle, and if you want to do it again, fold it again. Now find the part. You see there should be the smallest part on here, smallest edge, and just cut across that. Okay, so effectively cut your thing in half. Again, the instructions online which I'll send to you will hopefully explain this a lot better. Now I've got the top part. Oh, and cut the nib off the top little corner. Now if you want the instructions, I'm doing this very quickly. Fingers crossed this has worked. Yes, I've got a parachute. Nice round parachute, and you can make more and more of those. Okay, and that's the easiest way of bringing your astronaut down safely. Now, as I say, I will send around. We're going to send around the pack because I appreciate that was done very, very quickly, and you can do this at your leisure. Okay, that you know, I made it look like it was done in a couple of minutes, but it take a lot longer than that. The reason we've got a parachute is this is me again when we tried this over the summer, testing our parachute. It seems to be quite well, hopefully. Now, finally, why are we all doing this? Well, human beings are going to go to Mars soon. Okay, we're going to go to Mars, and it's going to be one of you sitting there watching this is actually going to send those people to Mars, might even be the first human being to land on Mars. Okay, it could be one of you. There's no reason it can't be. If you work hard, if you try, you could be involved in that, and I hope you will be. Okay, because it's going to be my hope that I can say I once spoke to the first human being to land on Mars. Okay, so we're going to end it there. Good luck, rocket scientists. We'll make sure you can get the pack. Hopefully you can rewind this. We've fingers crossed we're recording this so you can watch this in slow motion. But please experiment. Try this out. Let this just be the start of your journey into becoming a rocket scientist. And it's been my pleasure speaking to you today. Thank you very much. And I'll hand back over to the Microsoft team.
Thank you so much, Dr. Foster, as well. I want to say a huge thank you. That was amazing. Absolutely incredible. I am just quickly going to swap over and take over with my screen here. You will see a little bit of the back end there, everybody. So apologies about that. But we are going to be coding our own solar system now. So I know that we did have a sort of wonderful practical session there. Unfortunately, I have been informed that that may not have been recorded.
Oh, no.
So yes, unfortunately so. But I'm sure that resource pack will give you a big help out there. But we are going to be taking over now on the sort of Microsoft side. Once again, I'm looking forward to giving that resource pack a go at home myself as well. It was very entertaining. And
thank you.
No worries at all. So, who are we, though? That is the real question. And I'm hoping to answer that now. You are joined by me, Catherine. I'm on the left here. I am the presenter of this one. I'm going to be taking you through this nice digital coding section here. And I'm also joined by Adrian, who's going to be my moderator in the Q&A A. And do let me know, Adrian, is everything sort of looking and sounding okay from your end as well? I know I had to quickly share that.
Hey, Catherine, everything is crystal clear on my end. Hi, everyone. I'm excited to start this, and I'm also excited for the presentation that I've just seen. I love that, Mr. Simon.
Brilliant, amazing, absolutely. Having a great time over here. This is going to be a bit of a speedy session, so I do hope you are all ready to join us on this website here. It is a bit of a funny link. We're going to be using a website called Tinker today to actually do a little bit of block coding and make something that looks a bit like this, maybe with the less flashy background, but absolutely we're going to be doing our own solar system. Very exciting. It is AAA.ms/AAA-BKJD. I do have the long link here as well. And I'm going to be taking you through that step by step. So I'm going to be clicking on this. I'm going to be going over to the website and taking you through. Do give a thumbs up on that post as well in the chat. Once you have reached the website, it should take you to a page that looks just like this one. So I'm going to give everyone a little bit of time here just to get over onto that before we get going. In the meantime, Adrian, I was going to say, do we have anything else in the chat at the moment? Do you have anything that you need to let me know? And are you excited for this solar system coding session?
Oh, I'm so excited for this session. We don't have any questions in the chat, so we can get started. I can see that some people are just asking about space so much. Someone is asking even if there's ever been like an Indian astronaut. I actually made a quick search on that, and there's been at least 2 of them. So that's Raja Kari and Sunita Pandya. Sorry for the pronunciation. I'm really bad with names. But yeah, basically everyone can become an astronaut with enough dedication. And yeah, let's get started and seeing how this Tinker solar system works.
Amazing. Thank you so much. And absolutely, an astronaut or a rocket scientist. We used to know someone that we work with who's studying rocket scientist sort of things now as well. And he's doing very well. So absolutely, the opportunity is available for everyone. But something that, if you aren't interested perhaps in the physical side of it, maybe you want to know a little bit about coding. Maybe you want to write those programs that places like Imperial College and NASA are using. This could be a lovely introduction to that, and also nice space theme as well. So we're going to be creating something that looks a bit like the sort of scene that you saw at the beginning. This is an example of what that could look like. This is what we're going to be making today, and it's pretty cool, I must say. I'm very excited to start with this. I'm just going to close that down. But what are we looking at right now? So on the left hand side, we have our tutorial. This is going to be where we are going to know exactly what to do for our coding. We'll be following this step-by-step guide, and I'll also be taking you along, with me. We're going to be coding this together. So that's going to be very fun indeed. Over in this middle section here is where our code is actually going to run. So this is our workspace here. And over on the right hand side, we have our scene. So this is displaying exactly what we're going to be coding. And underneath, we have the different elements or parts of this scene above the top. So we have our planets and we have our stage, which is the background. All of the code that we write is unique for each individual part of it. So if I clicked on Earth, for example, left click, not right click, new trackpad, sorry. We will have the code specifically for that planet. But if I wanted to go change the background, I would need to click on stage. And I can see there's no code there right now. At the moment, all we've got are some planets and we've got some hexagons in the background. It's not too exciting, really. We need to add in quite a bit of code to get this working. So let's start the tutorial and we'll do this together. So do follow along at home. So the first thing we need to do is change this background. Blue hexagons look very nice, but they're not very appropriate for having the planets on it. So we want to make sure that we change that to something a little bit more space themed. Now, how do we do that? Well, there's a couple of ways of doing it, but we're going to go to first this stage section here on the right-hand side. And we're going to choose the gear icon just here over on the right. And then we actually hexagons look very nice, but they're not very appropriate for having the planets on it. So we want to make sure that we change that to something a little bit more space themed. Now, how do we do that? Well, there's a couple of ways of doing it, but we're going to go to first this stage section here on the right hand side, and we're going to choose the gear icon just here over on the right. And then we actually have a space setting just here, but you can also add a background yourself if you do want to by clicking the add background button. I'm going to stick with this space selection because I really like how that looks. Once you've chosen the background you want, either in add background or by picking the space one, just close that down. Now, the next do make a over on this side, it will actually list any background you choose space. You might have noticed you can also add a background from there if you're not happy with the way this looks, but I do like this lovely space scene over here. Once you've done that, simply hit next, just down on the bottom left to go on to the next instruction. So the next thing we want to do is actually add some background music to this so that there's a nice little sort of space sound, I suppose. Not very accurate, can't really hear sound in space, but we're going to be adding that in for a nice little effect here. And just as it says, we're going to just drag the blocks inside. So we have all of our blocks on the left, and we have an example of what it should look like down towards the bottom of our instructions here. So what we do is we drag in on start. We attach this forever block. Notice how it's a different shape and has a hole in the middle for you to put other blocks inside of it. This is sometimes called a C block, and this forever is also known as a loop. So we're going to make sure that things inside of this will just keep going forever, pretty much. So we want to have this play sound until done here, and click that inside. So it's almost like this forever block is sort of clamping down, biting into this play sound one. And just like before where we saw that empty grey square, if we give that a click, we can choose space music.
Hey, Catherine, I'm just going to stop you there for a second. Some people seem to have some issue with seeing your screen. Would you mind resharing your screen just for a second for me, please?
Yep, absolutely. Bear with me for a moment. It looks like my screen sharing has somehow cut from the live event, which is very interesting. Haven't seen that before. So apologies for that. Do let me know if you can see my screen now.
I think we can now. Let us know in the Q&A, guys, if you can see the screen.
So I do apologize about that. We're having a few technical difficulties on this one. But just to clarify what we've done, we're only on a few steps. So we're on step 2. We've added in our backgrounds here, literally just dragging that switch background block in and choosing space. And then we've gone to the next step over on this side now, and we've just added in a way to play music until we close this down. And that is literally just by, I'll show it again for you. So we're just going to add in the on start, forever, play sound until done, and then just click inside this little grey square. Every time you see one of these, it's a place to allow us to do a bit of customization. So I'm going to choose space music. Once you've done that, simply hit try out your code on the bottom left. There we go. So you can see what we had. We have one planet that's working properly. We've got Mercury in the middle there, but all of the rest of the planets, they're kind of not doing what we want them to. They're not spinning, they're not drawing a line behind, and we will need to fix that with our code. We did hear the music though, which was very good. Unfortunately, I don't want to be hearing music every single time I open that up. It might be a little bit distracting, so I'm going to mute that on my side, but do enjoy the little background noise for you. Brilliant. The next thing we're going to be doing is actually coding Earth's orbit. So that's going to be fun. We have our start location for Earth over here, just making sure that it starts over on this right-hand side. And you'll also notice that at the top here, it does say Earth, and it says Earth on the right-hand side. So we've actually swapped from the stage code to Earth, and that's where all of your other code has gone. It's still there. You can swap back if you want to, but we're talking about Earth this time. So let's take a look at what we need to do. Well, it looks like we're doing the orbit for this one, and we want Earth to be orbiting forever. Of course, we don't want it to suddenly stop in the sky. That would be catastrophic for us. So how do we make sure that it spins forever, and how do we make sure that it orbits forever as well? We can use code. We can use code, and it's going to be amazing. We're going to do the on start because we want it to start spinning as soon as we look at our solar system. We want it to spin forever using this block on the left. And then we need to tell it exactly how many pixels it should move, so how quickly it should be going around the sun, how much of an angle it should take to make sure it's going in that lovely circle, and also sort of the speed at which it's going as well. So this weight over here means that the planet won't whiz all the way around, it will just keep doing it step by step. And these values aren't right at the moment. So yes, we're moving 10 pixels. We have a 15-degree angle. We'd have a way different orbit there. We'd be cycling all over the place. So we definitely don't want to do that. We want to make sure that we change these values. Notice how they're in that gray once again, indicating that we can change them. And looking at what we need, it's actually 9, 5, and 0.08 for these values. So let's just input those. You can see here, I click on the 10, and on my keyboard I can just put in 9. And it's the same for these degrees here as well. I'm just going to pop in 5. And then for the weight, it can be a bit difficult to see, but it is 0.08. Brilliant. Once we've done that, I'm actually going to play my code again. And I don't have a try code button down here, but what I can do is hit play down in the bottom right. And it's very difficult to see, but you can see it orbiting. If you do want to expand that, absolutely use this little expansion button just in this scene here, this video scene. And we can see now that our Earth is going around the sun, which is just what we wanted. I'm going to stop that for now. I'm going to minimize that just using these buttons down at the bottom right and go on to our next step. So one more thing that we want to do is basically do this for all of our other planets. So yes, we've got Earth working, Mercury's already got all of its code, but we need to check all of the other planets that we have. And we have all of those different measurements that we can input into these sort of variable parts here over on the left hand side. So on page 5 of 12 is where you're going to find all of the different measurements and the code that you can use to sort of program the orbits for each planet. I'm going to start with Neptune as it's at the top, even though it is one of the furthest away, as you can see, and start on adding all of my code. So I like to add in the blocks first and then change them afterwards. There we go. And Neptune, let's have a look at what Neptune needs. It needs 19, 2, and 0.5 seconds. So again, just like before, I'm going to change these over. Oh, not 152, that's going to be far too much. There we go. And here we are. Let me just check 0.5. Wonderful.
Awesome. Hey, Catherine, after this, could you mind showing us again the music part?
Yeah, absolutely. You know what? You can always rewind the live stream just as a reminder, because I know we are running a little bit low on time here. But if it is the music part, you want to go back to page 3 of 12, just down at the bottom. It'll open up your stage. And again, all you have to do is drag out these blocks. So it looks like this. I'm just going to show you again underneath. Make sure to put this play sound until done inside the forever block. And then just click in this grey square here and choose space music. If you don't have that, click add sound and search for space music. The sound on mine isn't working right now because I've chosen to mute it. So do be aware that that could also be something affecting you.
Awesome. Thank you so much.
No problem. I'm just going to pop that back away. I've already got my blocks in here. And then move back over to the step we were on, which is step number 5. And again, I will be basically just adding the same code to each planet as I go down the list. Not the sun, of course. We are orbiting the sun. It is not orbiting us, as was once thought. And I can see Mercury's got enough code. We've got Venus as well. We've just done Earth. So what do we need to do next? Well, it is Mars. And you can see exactly which planet you're targeting by looking on the top right for where it's highlighted. And let's just keep adding that same code over and over again, and then checking for the measurements that we need over on the left-hand side. So we're on Mars, which means we need 11. 4. Let me just check that. 4. And then at the very bottom there, we want 0.1. Perfect. And we just keep going down the list. It's a nice way to sort of get that ingrained and sort of repeat there. There is a lot of repetition in coding because if this works, why wouldn't you want to copy paste it and just change a few of the numbers around, right? So this time it's 10. We've already got that. 2.4. There we go. 2.4. And then 0.2 down at the bottom here. So let me change that. While I'm doing that as well, Adrian, as I will just be doing the same thing over and over again, do we have anything else in the chat that I should be aware of?
Hey, Catherine. Not really. We had a few questions, but we pretty much tackled them. We made sure that everyone has video and audio playing on their side. So I think we're good for now.
Amazing. Thank you so much. Let's give this a go. So this time we're doing Saturn. Let's have a look at that. So we've got the 12.5, the 2.1 over here, and then the 0.3. Then Uranus just underneath, same again. So you can see really practicing that coding here. Now, if you were coding with a less blocky type of code, absolutely, you would have the ability to copy and paste. But we like to use blocks here, at least for when we're starting out, just to make sure that everybody can follow along. If you've ever seen I'm not going to say true code because this is absolutely real coding, but if you ever see code in a text-based form, it can be a little bit tricky to look at. So this is a nice way around that. Everything, of course, color-coded here. And interestingly enough, we do also have Pluto at the bottom here. Now, I'm in two minds about including this. I think we will, but it's not really a planet anymore. It's a little bit too small. So I'm going to keep it in there. I don't want to make it feel left out. We could remove it if we wanted to, but I'm going to allow it to stay. And there is even a little bit later on, which we may not have time to get to in this session, about adding some information to the planets. And you could then point out that perhaps it's not really classified as a planet anymore. So it could be a good bit of learning over there. Brilliant. So let's take a look at what we've got. We've got Pluto on here. I'm just going to double check all of my planets have the right code. So Neptune up at the top, I'm looking for 19 and 2. Yep. Sun, of course, we don't need that to have an orbit. Mercury was done for us. Let's have a look at Venus. Also done for us. Very nice. Earth, we did the step before. Mars, 11. Perfect. Yeah, looking good. I hope you're all being able to follow along at home as well. Remember, these may look like 1, 2, and 3, but there actually is a little point there. So do remember that it's more like 0.2. Got Saturn on here as well. Uranus just down a little bit further. Perfect. And then Pluto right at the end there. Really far out and very small, as you can see. Once you've done all of that, remember to hit try your code on the left here to make sure that everything is orbiting pretty much as you'd expect. Brilliant. I'm just going to double check Neptune. I'm looking like it looks very similar to, let's have a look, 19, 2 degrees. Yep. They look very similar on my side, no matter. On to the next step. So the next thing we want to do is make sure that the planets draw a line around their orbit, sort of a line follows behind them as they make their way around. And how do we do that? Well, we're going to be using just the same set of code for all of these once again. We can choose any planet we want to start with. And we're using this green code over here. So it's on start, pen down. So that's telling the computer to start drawing a line behind this. It's put its pen down on the paper. Imagine it like that. We're setting the pen size to 1. And then we're choosing our pen color. So this is the thickness of the line behind it, and this is the color of the line. This is in a sort of a hex code format. So don't be alarmed if you see all F. That just means that all of these colors, this red, green, and blue, is turned up to full. once you click on that, as I said, it's sort of in that grayed out square. We can choose exactly what color we want. We have some colors down on the right hand side, or you can pick your own by clicking and dragging and choosing which one you want. So what have I got? I've got Neptune here. You know what? I think I'm going to give it this nice dark blue over here. You can choose a different color for each planet if you wish, or you can make them all of the same, that cyan color in the middle there. It's entirely down to you. And once you've done one planet, just like before, we're going to be going through and repeating that code once again. You can change the pen size if you want as well, if you want to make the lines a little thicker. A pen size of 2 can look very nice. I'm going to keep it to 1 for now. And again, you can choose whichever colors you like as well. So Venus, I'm thinking, you know what? Let's give that an orange. Earth, of course, our humble planet that we live on, very cool. The fact that we get to live on this, one of the only planets, well, the only planet in our solar system to support life as we know it, and definitely very thankful to be to have such a nice atmosphere as well. Although I know Mars now is where we're looking to colonize potentially in the future. Lots of people starting to go there. Very exciting there too. How is that chat looking, Adrian? I know we are flying by on this one.
Oh, we are just excited to see what's next. Also, what's the color that you're going to choose for Saturn? I'm actually quite curious.
I'm feeling kind of yellow because this picture looks yellow, but again, I'm trying to sort of match them a little bit to the colors that there are, but I don't want to have 2 of the same. So I've chosen orange for Venus. I'm thinking Jupiter. Maybe I might go for, I mean, this orange is pretty good, but maybe if I want to change that, maybe I want it to go like a bit more red. Yeah, let's go for that.
Sounds like a solid choice.
A solid choice. I'm glad you agree. And then in Saturn, I am going to stick with yellow to sort of match the planets up. But again, your choice entirely what color you pick. Make it whatever color you like the most for each planet. And we've got Uranus down here, which again, I'm tempted to put that cyan, but we've already used that for Mercury. So let's pop that in here. Maybe I'll go for a bit of a turquoise there. That'll be nice. And then finally, Pluto, the kind of non-planet here. Bit of the imposter amongst all of these. And I think I'll just leave that as white because it'll be nice to have that. Or maybe, you know what, maybe I will just make it a bit of a color, maybe a bit of a sort of gray there. Lovely. So I'm just going to go through my planets once again, just to check that all of them have this section of code here. Brilliant, that's all there. And again, if you do want to make your pen a little thicker, size 2 looks rather good. You can of course just click in here and change that. You can make it as big as you want. Maybe you want it the size of the whole planet. That could look pretty funky as well. And finally, once you're done, just like before, you scroll down to the bottom of your instructions and you've got this try your code section. Amazing. So now we have all of our planets drawing a lovely line behind them in the solar system to show their orbits, looking very cool here. And you can see sort of Neptune starting to overtake Pluto there. It's a bit more of an easy thing to spot. We can hit next and add in something very important for our stage here. So what I'm going to show you is if I expand this and then hit play, the old lines that we've drawn don't actually go away. Our planets reset, they go back to their starting positions, but the lines don't. Now we want to make sure that this looks nice and clean when we start our solar system, and it's very simple. We just add one block underneath this switch background to space. After we've swapped the background over to space, made sure we have that space background, we just want to clear any of the pen lines as well. Notice how this is in green, as it's referring to those pen lines that we drew before. And now, when I hit play, I'm going to expand up, I'm going to refresh. You'll notice that while the lines do stay there when I stop, the minute I hit play, it will clear all of those lines and we can have a nice fresh start. So very nice that one simple line of code will do that. Then one of the last pieces that we have for this, the rest of these are kind of little bonus activities. We can label our planets. Now it's highlighted the sun for us already. So if I go to try the code and then click on sun, It'll actually tell me that it is indeed called the sun. Now, that may not be super helpful because I think we all know the sun, but with the other planets, we want to name those to make sure that everybody knows exactly what they are. You can see Mercury is labeled as well, but nothing else. So it is our job to label all of the planets. How do we do that? Well, we use another piece of code, which is when actor click, say, and then you put in a bit of text for 2 seconds. So it basically just makes one of these actors over on this right hand side, which is our planets in this case, have a little speech bubble and actually say something when we're clicked on them. So we want to just swap over to our planet. I've gone back to Neptune here. Drag out these blocks. So you've got when actor click and then say. And then just inside this little pale square, just like before, we can write whatever we like in here. So I don't have to have it say Neptune, but I am going to because that's going to make the most sense. So Neptune. And just like before, just to get you into the habit of using this code, we're going to be repeating that throughout the rest of these as well. So I'm going to check my others. My sun works, Mercury works, Neptune is looking good, but we need to add one for Venus, named after the goddess of love. So pretty cool indeed. Let's pop that in there. How's that chat looking, Adrian? I know I haven't checked in for a while.
Oh, we are doing just fine. So I'm excited to see how quick you can go and name Earth, Mars, Jupiter, and Saturn.
100%, because we want to make sure that all of our planets are labeled in case someone who's learning about the solar system and doesn't know what these planets are already called wants to take a look at our work. So let's do that. Let's add all of these in. And again, remember, if you do make a mistake anywhere, honestly, you can always try again. It's really important with coding not to give up when you're trying to code something difficult. Sometimes things don't work in the code and you need to go back in and fix it. It's an important part of the process and also known as debugging because you're trying to get all of those little bugs out of the code. And it's important for big programs, small programs, and of course, for our solar system. So it's all part of the process. If you do make a mistake, just try again. And also with coding, just like we did with the practical rocket that we made earlier, it's all about experimentation. So think of something that you'd like to do with this and then experiment to see if you can make it happen. I know Adrian does quite a bit of coding in his spare time when he's not studying, and I think you can probably tell us more than most that you need to do a lot of experimentation when coding. Hey, Adrian.
I would say 99% of the time when you're coding, it's not gonna work. But for that 1% when it does work, that's that you have reached the pinnacle of coding.
There you go. And you see, and to be honest, if we can do it, like I never had experience of code before working at Microsoft. I'm not Adrian, I'm not building programs in my spare time, but even I can make a nice little solar system here. And as he said, most of the time it won't work. And that is why we're using the lovely tutorial here. So now that when I click on my planets, they all say their name for a couple of seconds, which is really, really nice and a great way to sort of show off exactly what we have in our solar system. Once you've done that for all of your planets, just like before, hit next. And now we have our bonus steps. So I would love for everybody to give these a go on their own. You have instructions over here. You'll be learning how to do things like change the pen color so it's like a rainbow pattern in the background. You can choose to have a little dialog box pop up. I am just going to show that for the sun just to show what that looks like here, just to explain that. So if I pop that underneath this show dialog, I can put whatever I like in here. So I would advise you to do a bit of research about the planets and then put a cool fact in there. I'm going to put this is the sun. It is our star. Just something very simple, but I would love for you to put some more information there. And then once you've done that, just to show you what that dialog box looked like, it will say sun for a couple of seconds, and then we'll get this pop-up. And you can make it say whatever you wish. So be as creative as you like. The other steps as well, adding sort of rainbow pen color there. You have to do them each step by step. You can change the pen color and a few other things as well. You could even make a quiz inside of this if you wanted to. There's lots of different things you could do. And please experiment. Once you have given everything a go, so for example, if I just pop the pen color one in here, go to next, you can see you can edit your own planets over here. And if you finish the whole tutorial and click done, you actually have access to a lot more coding options here. So if you ever wanted to experiment with things, this is the place. But unfortunately, it has come to the end of our session. There is that nice little bonus activity for everybody there. But from me, it is a huge thank you once again to Stem the Violence for helping put these on. A massive, massive thank you to Dr. Simon Foster here from the Imperial College. But also, we want to say a huge thank you from us. We have a little feedback form here if you want to fill that in. Let us know how we did. But with that, I'd like to first hand over. Are you there, Dr. Foster?
I am. Hello. Sorry, I haven't got my. Can you hear me?
Certainly can.
I haven't got my camera on. Sorry, but yes, thank you very much, guys. Sorry.
Brilliant. No problem at all. And
Oh,
again,
thank you very much for today. It was lovely to be here, speak to you all, and I really appreciate giving me the opportunity. So hopefully you enjoyed it, and you may have learned something along the way. Fingers crossed.
That's the same from me as well. I do want to say a big thank you. Hope you've learned something from both of us. A little practical, a little bit digital there as well, and all involving, of course, Stem the Violence. Lovely to have you with us once again. We hope we'll be having you for some more sessions. Adrian, do you have anything you'd like to say to our lovely audience?
I just want to thank everyone for the patience. It's hard following so much information, but it was quite lovely being presented by two professionals. And of course, guys, keep on learning about the universe. There's so much more to learn about it, and it just gets cooler and cooler, as I'm sure Mr. Simon here will like to let us know. Well, thank you guys for joining us today, and have a great evening.
Have a wonderful evening, everyone. And with that, that is goodbye from us.